Hey guys, I'm Jonathan. Welcome to this new video. We will learn how to do this. Just before starting the video, I wanted to tell you that you can download the source file. The link is in the description. If you discover this channel, I currently publish 2 to 3 videos per week related to filmmaking, advertising video, and 3D, with Cinema 4D, Blender, and Houdini. So, if you are interested with these subjects, don't hesitate to subscribe. I thank in advance all the people who like, comment, and share my videos. You know it helped me a lot. If you want to have help, you can join the Discord server and the Facebook group. The links are in description. We don't waste any more time. If you are ready, let's go. Just before starting, for this animation, I was inspired by a project I saw on Behance. An advertisement for a watch, the TAG Heuer Aquarius or Superdiver. You can see the complete project on Behance. So here, if I press play, I was inspired by the shot that's going to come right after this one. So here it is. Feel free to check out the full project. It's really interesting and the video is amazing. So here, as usual, I've got my final file. So I'm going to explain a little bit how I built this scene, and then we're going to rebuild it from scratch. So here I have my first node, in black, which I called RND for research, so this is where I did all the construction of my scene. Here, the blue nodes, as usual, are my rendering nodes. If you've ever watched my Houdini videos, you know a little bit about how I work. So here I have a first render node for the particles, a second render node for the watch, and a third render node for what I'm going to use as a floor. So this is just a shot. Then, here, I have 3 lights, so 2 area lights, with redshift, and a light dome light, with an HDRI image. So here, you can see on my stage that I have a first rectangle light that is used as a backlight, and I have a light that is used to light the stage globally. A rather large light, with a rather low intensity. And then I also have my HDRI, which you can't see here on the stage. And then, I have my 2 cameras, so a camera quite close to this level, and a camera in top view, which you can see here at the viewport, at the top. So here, first of all, I'm going to disable all of that. So I select my nodes in blue. I select my lights, I disable, and I select my cameras, and I disable them. So here I'm going to go to my black node, where I created my scene, and I'm going to explain a little bit about how I created this little animation. So here, on the left side in the blue square, this was just a test made before doing the main simulation. So if you download the source file, you also have access to this little animation. So I'll show it to you quickly. So here, if I activate it, we can see that we have a displacement of the particles based on a smoke simulation, and we also have an attribute that manages the color at the level of the particles. Then, on the right-hand side, we have all the nodes that will be used for the animation with the watch. So here, all this part is what corresponds to my watch, with the model that I imported in FBX. Here, I have 2 tubes that will be used to remove particles. You will understand why later. And here, I have my smoke simulation on the right, my particles on the left, and here, the pop network, to be able to move my particles using my smoke simulation. Then, here I have my output node. I have here a color node to visualize my attribute, which will be used to color the particles like here. And finally, I have a last part at the level of the node, which correspond to my end node, so the last part of my scene before going to the render. So here, I did a time remapping with this node here, so I can do a slow motion. Then here, I converted my colors to be able to use them for rendering. And here, I cached all of this, and I added a node at the end to be able to use them in my blue nodes, which we saw at the beginning. So here, what we're going to do is we're going to add a new node, and we're going to start all this from the beginning. So here, we go back to object mode, we press the tab key, and we type geometry, and we add a geometry node. So here you place it wherever you want. You can change its color by selecting it and pressing the C key on your keyboard. And here you have the color palette, if you ever want to change its color. You can also rename it here by double-clicking, and once you've done that, you'll double-click inside. So here I'm going to be able to directly import my node file, so I can import my file. So here, I'm going to press the tab key, and I'm going to take my first node file. I'm going to place it here. So here I'm going to go to the little sheet, and I'm going to select my FBX model. So you'll have it available in the source file, if you ever decide to take it. So here I'm going to go and get my template. So here, once we have added our watch, we can see that it is much too big, because on Houdini, the scale is meters. So here, it means that we have 3 meters. So the first thing to do is to reduce the scale of our watch. So I'm going to take a node transform, and here, in the uniform scale, instead of 1, I'm going to put 0.1. So we won't be working at the scale of the watch. But here, in terms of proportions, it looks pretty good to me. Here we have 1 meter. So we have roughly 20 centimeters at this level. So it looks good to me. Afterwards, for the particle simulation. So I'm going to remove the texture of the V. So here I'm going to deselect it. And then I'm going to add my Boolean node to be able to do a subtraction and keep only the watch face. And we're going to remove the glass. So here, I'm going to put my transform node on the left side. And on the right side, I'm going to add the object that will be used for the subtraction. So here I press tab, and I'm going to add a tube. And this tube, I'm going to increase its columns. I'm going to put 128. I'm going to put a merge node here, which will be used to visualize my watch plus the tube. So here I select this node. With Shift, I select the second one, and I put them here in the merge node, and like that, I can visualize both. So here I'm going to do end caps here too, to close the tube, and then I can simply reduce its radius. So here, I'm going to copy this value. So copy parameter, and I'm going to paste it at this level. Paste relative reference. And so, the value in green will always be the same as the value here. On the left, I'm going to be able to decrease the diameter. So here I'm going to put 0.1675. That doesn't seem too bad. So here I'm going to be able to delete the merge node. And I'm going to link the tube this time in the Boolean. And here, we'll see that we've done a subtraction operation at the level of our watch. And we've got only the dial. Then, once we've done that, I'll be able to add the match size node. I'll come and visualize it. And here, in justify Y, I'll put min, the watch face, which will be placed on the ground. So it will be perfectly here, at the 0 value, on the Y-axis. Then, I'll be able to add a node transform, which will be used to make the animation to make the dial fall. Here, I'll rename it animation. I'll select it, and I'll put it in green. That way, I'll remember that this node will contain keyframes. Then here, I'm going to be able to add a null. And so here, I'm going to rename it outWatch. This will be the output of our watch. Then, we will add a collision node to be able to make a collision at the level of the particles. But we will do that later, once we have done our simulation. So here, we already have our first part. If you want, you can select all the nodes and put them in a small panel by clicking here. And that allows us to stay organized at the node level, to be able to remember them later. So here, I'm already going to be able to do my smoke simulation. So here I'm already going to be at frame 1, at this level. I press tab, and I'm going to add a circle. So circle, here I'm going to select it. I'm going to put it in polygon. So by default it's already in polygon. I'm going to increase the subdivisions. I'm going to set it to 128. I'm going to visualize it here. And in the orientation, by default it's XY. And I'm going to set it to ZX so that I can lay it flat here, at ground level. So right now it's way too big. You can see that it has a radius of 1 meter. So here, what I'm going to put is 0.275. So I'm going to leave it like that. And then I'm going to put a poly extrude node here, so I can extrude it. Okay, and I'm going to put 0.1 here at the extrusion. So next, I'm going to remove the output front, so that I can remove the face. And then I'll be able to put a match size directly. And here, as before, we're going to come to the Y-axis. And we're going to put min, so that we can place it at ground level, exactly as we did earlier, as we did for the dial of our watch. Then, here, we can add the normal node. So here, we can visualize the normal by clicking on the little tab here. And I'm going to switch the viewport to dark mode. So for that, I press the D key. I go to background here. And instead of light, I'll put dark, so we have a black environment. Then, here, I'll be able to put a point vip. And then we'll use the normals that we added just before to add speed to our smoke. So there, we can for example rename it normal to vel, for normal to velocity. And then I'll go inside, double click, simply select my normals, and I'll put them on the velocity, in output. Then, we're going to use this for the smoke simulation. So here we'll be able to place a null, which will serve as a basic shape for the smoke emitter. So here I'll put OUT emitter. And then I'll be able to place my Pyro source node directly. So the Pyro source node will add points on the surface of our emitter here, which we created just before. It will add the necessary attributes for the smoke simulation at the level of these points, and then we can activate the simulation with the Pyro solver. So here, at the Pyro source level, at the mode level, we can already set surface scatter. Here at the initialize level, we will set source smoke so that it will already create two attributes, the density attribute and the temperature attribute. And then we can change the resolution of the points. If we leave it at 0.1, we can see that we don't have enough points on our surface. So we'll change the value to 0.02. So here, we can see that we already have more points on the Pyro source. So what we can do here too before moving on, because we'll need to put exactly the same value on the next 3 nodes. So here what we're going to do is add a null node. Here I'm going to change its shape. I'm going to put it in a circle. At this level, I'm going to call it controller. And then here at the level of the null, we can go into the parameters, in the little gear at this level, to edit parameter interface. Here, these first 2 files, we're going to make them invisible. So I'm going to do apply. And then we'll take a float, we'll put it inside, and then it will be used as a resolution. So I'll call it resolution. And then at the label level, same thing, resolution. I do apply, accept, and then we can see that we have created a parameter. So we're going to set it to 0.02. We're going to right-click, copy parameter. And we're going to be able to paste it right here. So paste relative reference. And this means that in the source Pyro, it will take the value that we added here in the controller. So that way, we can copy this value and paste it in different places. And we'll have the same value for all the places where we've pasted the controller parameter here. So then, here, after the Pyro source, we won't have anything because we don't have the smoke simulation yet. For that, we need to add the volume rasterize attribute node. So right here. And we'll add the attributes to it. I also forgot, in the Pyro source node, we also need to add the third attribute, which is the velocity, which we had configured here with the VOP point. So here, I'm going to click on plus, and I'm going to add velocity here. And so for the moment, we'll leave it like that. We have our 3 attributes, density, temperature, and velocity. So here, in the volume rasterize attribute, we're going to select them. So here, I select this node, and an attribute. I'm going to select my density, my temperature, and my velocity. And so, as before, here we need to change the voxel size to increase the resolution. So we're going to look for the controller parameter. Right-click, copy parameter. We're going to the volume rasterize, and we're going to right-click, paste relative reference. So there, we can see that we already have some smoke at this level. And so to be able to do the simulation, we need to add the Pyro solver, which has been added since Houdini 19. So I'm going to place it here. I'm going to link it to this level. And like before, I have to change the voxel size here to increase the resolution. So I'll simply copy the parameter from my controller. Copy parameter. And I'll paste it here in voxel size. Paste relative reference. And so, if we change the value of our resolution, we can go into the controller, change the value here, and it will change the value of these 3 nodes, rather than changing them one by one. So here, if I press play, we can see that we have our smoke simulation. So here, it goes up. It's normal because we have gravity. So here, I'm going to go into the Pyro solver. The first thing to do is to go into shape, here. In the second tab, we have the gravity. So here I'm going to put minus 9.8. So I'm going to invert the gravity. And here, I'm going to go to bound. And in bounding conditions, I'm going to close on the y-axis. So on the y-axis, I'm going to select close below. And then if I press play, we can see that we have our smoke simulation. Like this. So here, at the Pyro source level, we can change the speed. So here, at the velocity level, we can change the scale. So we can set it to 5, for example. And we will have a faster simulation. So here, I'm going to press play. And we can see that we have a faster simulation. Then, in the solver, we want a simulation from frame 24 to 36 and from frame 0 to 24. It will be the animation of the falling watch. Once the watch hits the ground, we have the smoke simulation that starts, and that makes the particles move, which we'll add right after. So here, to do this, we're going to go to the Pyro solver. We're going to go to sourcing here. And we're going to activate the limit source range here. We're going to activate the little panel here. And we're going to put from frame 24 to frame 36, as we said. And then, if I press play, we can see that we have nothing until frame 24. And at frame 24, the simulation begins. So here, at the level of the Pyro solver, what you have to do is to play with the parameters of the noise. Here in shape, you have several parameters, which can vary your smoke simulation. So there, you have to play with the different parameters to obtain the shape you want. And then, the shape of this smoke simulation will determine the movement of your particles thereafter. So, if we leave it like that, we'll have a really uniform displacement of the particles. So it might not be really natural. So what I recommend you to do is to activate the turbulence right here and here to play with the different parameters. So what I'm going to do is I'm going to leave all the settings at their default values, except that I'm going to put 0.125 here for turbulence. And I'm also going to activate the shredding. And I'm going to leave all the settings at their default values. So here, if I press play on the simulation, we can see what it looks like. So this is not really what I'm trying to achieve. So here at the Pyro source level, at the velocity level, instead of 5, I put 2, and here at the pyrosolver level, at the end, at the level of the second panel here, the gravity I'm going to put it at 0. So here, we can see what it gives, and we can see that it's already much nicer. We have little undulations here at the level of the smoke, and it's going to be nicer afterwards at the level of the particles. So afterwards, you can obviously play with the different parameters here to try to get a different shape, to have a different simulation afterward. So once we've done that, we can add a null here, which is going to be the output for the smoke, so we'll rename it out smoke. And then we can add the popnet directly. I'll type in popnet, and I'll leave it like that for now. And we'll come here and add our particles. So here, for this, I'm going to add a grid. In terms of the size of the plane here, instead of 10, I'm going to put 4 here. In terms of the columns, I'm going to put 2, and 2 right here. And then I'm going to put my polyextrude node. I'm going to be able to extrude on 0.1. Here I'm going to be able to close the face at the back so I can create a cube like this. I'm going to add the match size node so that I can put it on the floor like before. So here at the match size level, I'm going to go to Y, and I'm going to put min so that we have our cube here at 0 on the Y axis. And then I'm going to put the node point from volume. And then it will create several points based on the volume of our part. So here, I'm going to set the particles to 0.15. For example, for the moment, and for the jitter scale, I'm going to set it to 1 to have something a little more random in the points. Then, after that, I'm going to add a null, so it will be out for our points. And I'm going to connect this output here in the first input at the popnet level, and I'm going to connect the smoke here in the second input at the popnet level. So then, here I'm going to visualize the popnet. I'm going to go inside, and here what I'm going to do is I'm going to move my source up a little bit. I'm going to go inside, so I'll select it like this. And then I'm going to put all point, so all the points will be particles. Here, we have to use first context geometry. It will correspond to the grid we added just before. And then here, in birth, we're going to go to activation, and we're going to put $FF == 1. So that means that it's going to emit at the first frame. So if we go to frame 1, we can see that we have 1. And when we go to frame 2, we have 0. And then we have 0 all the way through. So it will only transmit at frame 1. Okay, so next, we're going to add the pop advect by volume node. And this is the node that will allow us to move the particles from a volume. So here I'm going to put this node right here. And so here, instead of SOP, we could come and select the null. But as we linked it to the second entry of the popnet, we're going to select here second context geometry. And here, instead of update force, we're going to put update velocity. So if we press play, we'll normally already have something. So here we have our particle displacement based on our volume from frame 24, as we had activated our smoke simulation. So here, if we look at our simulation, we can see that our particles go here in negative value. So what we can do is add a node merge. I'm going to put it right here. And I'm going to add a ground to be able to add collision at the ground level. So here I'm going to put ground plane. And I'm going to put it here in the merge node. And I'm going to shift to so I can put them in the right direction. And so here, if we press play, we can see that we don't have any particles crossing our ground. And they can also bounce off the plane that we added. So now we're going to add a few more small parameters to the popnet. So here, I'm going to go inside, and I'm going to add a static object, which is going to be our collision. So this is going to be our watch. So here, I'm going to put the static object here, and I'm going to link it here in the merge, and I'm going to shift to be able to place them correctly. So here, we're going to select our watch with the static object. But before that, we have to go here to our watch, and we're going to add a node here, which is called collision source, right here. And here, we're going to add a null on the left. So we'll call pol for polygon, and a second null on the right, which we'll call vol for volume. And so, if we look at this geometry, we have our polygon here. So our geometry. And here we have our volume. So for the moment, it has a much too low resolution. So I'm going to go to the source collision level here, in volume, and there. I have to change the voxel size. Here, I'll leave it at 0.002. So this null here will be used as a collision in the popnet. So here, I'm going to go into the popnet. I'm going to go into the static object, here. At the level of SOP path, I'm going to select the null that will serve as a polygon. So here, it's called pol1. And here in collision, I'm going to put in volume sample mode here. And then I'm going to come and get our volume proxy. So it's going to be the null, which we called vol1, which is right here. I'm going to accept it. So there you have it. We have our watch, which will be used as a collision for the particles. Here I would like my particle movement based on the volume to be done only outside the watch, and that the particles inside the watch remain like this. So here, we need to add a pop group, and then we can create a cylinder, which will be used as a group for the particles inside, to keep them intact, and not to move them with the smoke. So here, I'm going to go back to my R&D tab. I'm going to add a tube. So I'm going to press the pink tab here to make my watch visible, to know a little bit what diameter I have to choose for the tube. So here, I'm going to increase the resolutions to 64. I'm going to put end caps here. And at the radius level, I'm going to decrease it, like this. That's it, about here. It doesn't have to be super precise. And then here, I'm going to put a null that I'm going to call pop group. So here, I can come into the popnet again. I go here into my pop group, and there in bounding, I can select by default a box, a sphere, or an object. So I'll choose object, and I'll select the tube that we just created. So here, SOP path, I'm going to select the null that I had called pop group. So here, we can't see it too well because the particles are blue and the viewer is blue. So I can come here and change the color from blue to red. And then we can see that our tube is here. And it will keep the particles inside. So here, I'm going to invert. And then we have to go to the pop advect by volume. And then, we're going to activate it only for a group. So we have to give a name to this group. I'll call it inside, so it will be the particles inside. So I'm going to go into the pop advect by volume. And here at the group level, I'm going to put inside as well. So basically, this node will be activated only for the inside group. Now, if we go back to this level and press play, we can see that we have particle movement only on the particles outside the watch. So this is exactly what we want to do. Then, I can add a new pop wrangle node, and we'll add a little bit of code, simply to add color to the rendering, depending on the speed of the particles. So here, we're going to put f for float, at speed, which will be the name of our attribute, equals length for vector and velocity. I close with the parenthesis, and I put a here at the end. And then, normally if I go back to this level, I put a color node just after the net pop. So here I put my color node. I activate it. I go here. Instead of color type constant, I put ramp from attribute, and then we put attribute speed. And here, I can put, for example, the precept of ramp twilight shifted. I think it's nice. And here, I'm going to put it back to frame 0. I press play. And here, we can see that the color of the particles changes according to the speed they have. So that's a parameter that can be really nice after the rendering. You don't have to add it. It's up to you. So I put it in for my final simulation. But then you do exactly as you want. So here, once we've done that, we're done with the particle simulation. So now I'll be able to add a new null here. So I'll rename it outSim for the end of the simulation. And finally, I'll be able to do the last simulation, which will be the temporal remapping, to add a little bit of slow motion. So here I'm going to add the node DOP import. Here, I'm going to put the popnet in the DOP network. So I'm going to select the popnet. I'm going to put it inside. Here, in import style, I'm going to put fetch geometry from DOP network. So here, we'll have our simulation in this node at this level. Then I'll add the time warp. I'll activate it here. Instead of fit range, I'm going to put by speed. And so here you can place keyframes on the speed of your simulation. So for example, at frame 24, we can put a keyframe at speed 1. We can put up to frame 36, for example, at speed 1. And then, for example, at frame 40, we can put the speed at 0.1. And then I put another keyframe. So to add a keyframe, it's Alt, left click, and then, if I press play, there we have real speed, and then we have a slow motion, which we can set, for example, until frame 60. So there, Alt clicks, and then from frame 65, we can set the speed back to 1, for example. And I press Alt clicks to add a new keyframe. So there we have a slow motion, and again the real speed. So you can do as you like with the slow motion. Then, we'll add one last thing. It will be the .vop. With this node .vop, we're going to convert the attribute speed that we had added to put it in a value between 0 and 1. So there, to know how to do it, we have to go here to the output of our simulation. We're going to go in the geometry spreadsheet. We're going to look for the attribute speed, which is right there. And there, we're going to select the small arrow to classify them by decreasing order. And there, we're going to look at our simulation. And we can see that the maximum speed is at 2.1, approximately. So we're going to put 2.1. So here I'm going to go to the VOP point, double click. I'm going to put the bind node here. I'm going to put the speed attribute. Then I'm going to put it in a fit range. And here, the minimum speed is 0. The maximum speed we said 2.1. And we want to convert them from 0 to 1. So here, I'm going to put bind export. And I'm going to put speed at that level as well. So now we've converted our attribute from 0 to 2.1 to 0 to 1. So we can then use redshift. Then we can also specify that there will be no color variation with the speed attribute before frame 24. Before the start of the simulation. So here, we're going to put in an attribute wrangle. So there, we specified that before frame 24, we have no color variation on the particles. So then, you can put your file cache node right here, and you can put your output node, so null. So you can put OUT simulation. And so there, at the file cache level, you can, instead of constructed, put explicit. You can create a cache folder here. For example, instead of the geo folder, so cache divided by $OS. So that will be the name of the node. And then you can put, for example, particle advect, and then you specify the number of frames on which you want to run a simulation. So I had done from frame 0 to frame 96, so that's 4 seconds. So you set here the number of frames of your timeline. And then you do save to disk to be able to cache the simulation. But don't forget that here, by default, we had added a rather low value for the points to be able to read the simulation in real time on the screen. But if you want to have more particles, because there, the points will correspond to your number of particles. If you want to have more, don't forget to decrease the value here. So for my final animation, I had set 0.004. It seems, for the number of particles at this level. So it's up to you. And it also depends on the power of your computer. So that's it for the simulation. It's something that's quite simple. So next, we're going to go back to the object mode, and we're going to see a little bit, very quickly, how to do the shading and how to do the rendering. So here, before continuing, I just forgot to do the animation on my watch. So we have to go back to the node that we added, animation. We had put it in green too. So here, at frame 24, we want the watch to be at ground level. So I'm going to go to the animation node at the Y translation level. I'm going to add a keyframe. So here, Alt, left click here. And I'm going to go to frame 1. And I'm going to raise this value. I'm going to set it to maybe 1.5. And I'm going to add a new keyframe. So Alt, left click. I'm going to change the animation curve here. So here, with this node selected, I'm going to go to the animation editor panel. I'm going to press H to be able to recenter my curve. And here, I'm going to put this keyframe about like this. And this keyframe, I'm going to put it about this level. So here, if we look at what it looks like in the scene, I'm going to press play. And we can see that we have our watch falling. And when it touches the ground, we have our particle simulation. So for the rendering, we will use this node here to render our watch. And we will use the node here to render the particles. So here, I'm going to go back to the object panel. I'm going to add a new geometry node. So I press tab, I type geometry to add a new node. Here I'm going to rename it. I'm going to call it RNDR, part for particle. I'm going to go inside, and I'm going to put an object merge node right here. I'm going to copy the simulation node. So I'm going to do Ctrl+C. I'm going to go back to the object merge right here. And I'm going to do Ctrl+V at the object 1 level. So now we have our particles. Next, I'm going to add a second geometry node. First, I'm going to rename it RNDR watch. I'm going to go inside, double click, and I'm going to add a new object merge node. And this time I'm going to come and get the null with my watch. So here, I'm going to copy the OUT watch null, and I'm going to come back to the object merge, and I'm going to do Ctrl+V here. And then we have our watch. So here, these two nodes, I can put them in blue to indicate that they are my rendering nodes. I can go here to the particle node, and there we can see that we have two watches. So one watch is active and the other one remains motionless. So we have to delete this one in the particle rendering. So I'm going to put a delete node here. I'm here in the particle rendering node. I'm going to put delete. I'm going to put bounding box, like this, and I'm going to place it on my watch. So here, I'm going to increase the center on Y, and so I'm going to put it like this. And then, if we look at our animation, we can see that we have the particles and our watch. So here, we can also add a new render node with a ground, if we want. We just need to add a grid. Then, for the particles, if you use redshift, don't forget to select the particle rendering node here. Go to the little redshift OBJ panel, and then go to particles. And there will do render object as particles. And there, you can set the size of your particles. So I had set I think 0.1. Something like that. The higher the value, the more you'll have points, the bigger the particles. So after that, it's up to you to adjust according to the rendering you want to obtain. So then, just go to the matte network panel here. And then there, you can add your materials. So here I had my 3 materials that I used in the original version. So one for the watch, one for the particles, and one for the floor. So you just do tab, redshift, material builder. So you take this one, you put it here. And then if you go inside, you have the material to create at that level. Then you just have to link it to the object. So you have to go back here in the OBJ panel. And then, for example, for the particles, you can come here and render. Here you select the material that you have created for your particles. So there, you go to the small tab at this level. Just go to the material network. And there, you link the material that corresponds to your particles. So here, I'm going to put the particle material that I had created for my original simulation. And for the watch, I'm also going to select, and render, the original material that I had created. So watch. So there, I have the 2 materials assigned. And if we go inside the materials, I had used the precept at the level of redshift aluminum, and I had added textures, simply to add a little brushed metal. So I added a texture for the bump, a texture for the metalness, and a texture for the roughness here. So these are PBR textures, which you can download in the source file. And then, if we go to the particle material, I simply added a simple material. And I used the speed attribute, which we created to control the color of the particles according to their speed. And I added a black ramp, up to a sand color. So there you have it. And as far as the lights are concerned, I used 3 lights. One HDRI light to make an ambient light to make a lighting base. And I added 2 area lights to finalize my lighting. So, that's it for today. I hope you enjoyed the video. If you did, please feel free to like, subscribe and share to support my work. I see you next time. Bye.